Hi, I'm John Wellspring. I work at KERAMIDA here as a senior project manager. I do a lot of the air permitting work here, air dispersion modeling, air impact analysis, and risk assessment. And today we're going to talk about air dispersion modeling. Air dispersion modeling is just a mathematical representation of the dispersion of air coming out of an emission point, such as a stack, or it could be an area source, a storage pile, a volume source, a conveyor, something like that. And you determine what the impact is outside of the property line from emissions at a given point inside the property. So sometimes we do this for particular pollutants like particulate matter, NOx, VOC, carbon monoxide, sulfur dioxide. And other times we do it for specific air toxic compounds like xylene or toluene, or a heavy metal like arsenic or a chromium emission. The National Ambient Air Quality Standards define the targets that we're looking for all the criteria regulated pollutants, such as PM, PM2.5, PM10, NOx, SO2, ozone, that type of thing. And the state rules typically create the emission targets that we're after for air toxic components, such as the metals or solvent vapors and that type of thing. To do air dispersion modeling, you need to choose your model first. So there are screening models that are basically models where you can get some idea of what the impacts are going to be with a desktop model, where you just basically plug in input data and generate output data, and it compiles that data for a static wind direction and wind speed at different meteorological conditions. That's called a screening model. We can model using a more dynamic long-term model like AirMod, which is the preferred EPA model, and that uses actual meteorological data, typically over a 5-year period. It also uses terrain, elevation, height, so hills, mountains, that type of thing. Looks at your property line, the location of your facility, selects the topographic relief of that area, and define the time period, the averaging period that you want to model, and the emission rates that you want to model. So you plug in the buildings, the site geometry, the stacks, the stack heights, the velocities, the temperatures, everything that goes into the model to determine what the impacts are going to be. Generally, we're doing all of our modeling as part of an air permit application for a modification or construction of a new facility. And so they would let us know, hey, we want to do a certain level of permit that may or may not trigger air toxic impact analysis and or ambient air quality modeling. And depending on whether it does, then we would include that in our scope of work to help them obtain the permit that they need. Most of the time, air modeling is required by the regulator. If you're a major source and you're doing a major modification of a source that's subject to prevention of significant deterioration for any ambient air quality standard, you'll be required to do ambient air dispersion modeling. Yeah, there's several steps if a company fails to meet the criteria that needs to be met. So first thing, of course, is to look at lower emitting processes, air pollution controls such as dust collectors or thermal oxidizers, or catalytic conversion of something, say NOx, or scrubbers for SO2, that type of thing. So you can look at control technology. The other thing you can work with is the geometry of the building versus the stack. The higher the stack relative to the building, the better the dispersion. There's a phenomenon called downwash, stack tip downwash, that occurs. If your stack is too close to a building and it's not high enough to get over and overcome building downwash, then the wind that sweeps over the top of the building will actually pull the pollutants down to the ground. And you'll have higher impacts at the property line because of that. What you can do is increase your stack heights to overcome that so that you're above the building downwash, so that your air, when it leaves that stack, disperses over a wider area and results in lower concentrations. And so all that stuff you can basically work with to lower impacts and to improve the results of air dispersion modeling. KERAMIDA has the ability to do the modeling in-house. We turn our results around pretty quickly. We can run different scenarios and compare different scenarios and basically get our clients into compliance using our knowledge of air dispersion techniques and control technology and stack height versus building height to improve outcomes and to demonstrate compliance with the criteria that need to be met.